Hello, this is Ms. DB, and today we are going to go over solving two-step and multi-step equations. This is from Chapter 2, Section 3 of your book. Our objective is to solve equations in one variable that contain more than one operation. This is just an example of when in the real world you might see something like this. Alex belongs to a music club. These used to be quite common before Spotify and Pandora, and I know there's other ones out there now, but it used to be you could get this discount card and then you'd buy CDs. So Alex bought, let's see, she had to pay $19.95 for a discount card, and then she could get CDs for $3.95 each, which is really cheap. After 1 year, she has spent $63.40. So to find the number of CDs that she spent, you could write an equation like this. So this is $3.95 for each CD plus $19.95 for the amount of the discount card, and the total that she spent was $63.40. And we would solve this by undoing the operations one at a time. There's both multiplication and addition in here. So they require two steps to solve, and we have to undo them in the right order. It's basically the opposite order of the order of operations. So we would first undo what's being added or subtracted, and then we would undo what's being multiplied or divided. So first we will undo the adding $19.95, because that was the last thing that would have happened. And then we will next undo the multiply by $3.95, because that was the first thing that happened. So you do them in the reverse order. All right, let's look at these with a little bit simpler problems or numbers in them. Here we have 18 equals 4 times a plus 10. So the variable is a. Find the variable. The variable is a. What you want to think to yourself is, what is happening to that variable? What two things were done to it? It was multiplied by 4, and then 10 was added. So we have to reverse that order and do the inverse operations to undo them. So the last thing that happened was adding 10. So that's the first thing that we're going to undo. We're going to subtract 10. And again, you have to do it to both sides of the equation, just like in the previous two lessons, because that keeps the equation balanced. So we subtract 10 from both sides. Once you do that, you have a one-step equation that you've already been working with. It's just a equals 4 times a. So now we need to undo the multiplying by 4. And the opposite of multiplying by 4 is dividing by 4. So we divide both sides by 4, and we get that a is equal to 2. Oh, they didn't show the checking. The next thing you would do is you would check this by writing out your original equation, except where I see an a, I will put the 2 that I got for an answer. And then we will solve or figure out both sides of this equation and see if we get the same thing on both sides. So 4 times 2 is 8. 8 plus 10 is 18. And on the left side, of course, we have 18. So 18 equals 18. This is true. So we got the right answer. You should always check your work. Okay, here's another example. Again, find the variable. Think to yourself, what is happening to this variable? It is being multiplied by 5, and then 2 was subtracted from it to get negative 32. The first thing that we have to undo is the minus 2. That was the last thing that was done. That's the first thing that we will do the inverse operation for. So the first thing we do is the opposite of minus 2. The opposite of minus 2 is plus 2. So you add 2 to both sides. That leaves us with 5t, don't forget the 5 and the t, equals negative 32 plus 2. Now double check that. You should get negative 30. Negative 30. Okay, now we have a one-step equation. We have the variable t being multiplied by 5. What's the opposite of multiplying by 5? Dividing by 5. So now we'll divide both sides by 5 and get t is equal to negative 6. Don't forget the negative. Then we check by going back to our original equation, write the whole thing out, except instead of the t, we'll put our negative 6. And for my equal sign, I'll put a question mark by it, just because I don't know yet if it works. So now I do the work on this side. I go 5 times -6, that's -30, minus 2, and I want to see if that equals the right side. So -30 minus 2 is -32, which is equal to -32. So it does check, and I have the right answer. If you check it every time, you'll get the right answer, because if you do the check and it doesn't work, then you can go back and fix it and find your mistake. All right, we're going to do another example. These are a little bit tricky, and I do want to make sure that you know that you have to show your work on these. You can't just write that x equals 5 or x equals 10 or whatever it is. You have to show your work. So first we find our variable. This is stuff you do in your head, and the variable is x. And then you think to yourself, what is happening to that x? That x is multiplied by 7, and then a -4 is added to it. Okay, so we have 7x, and then -4 was added to it, and that's equal to 3. So the first thing that I have to undo is not the 7, it's this -4. Now I could subtract a -4, but it would be easier, like we looked at in our last, in 2.1, it's easier to just add 4 to both sides to undo the -4. So we will start by adding 4 to both sides, and you write that out on your paper, and that leaves you with 7x equals 7, because the -4 plus 4 is 0. You don't have to write this plus down, and you just have 7x equals 7. That means 7 times x equals 7. The opposite of multiplying by 7 is dividing by 7. So then we divide both sides by 7, and we get x equals 1. And then we check our answer by writing the original equation down, except wherever we see the x, we put the 1, because that's what we got for x. And we want to see if we get the same thing on both sides of the equation. So -4 plus 7 times 1 is 7. And -4 plus 7 is equal to 3. So 3 is equal to 3, so this checks, and we have the right answer. Here's one with decimals, so it looks a little harder, but it's really not, as long as you have your calculator handy that you can double check your math with. So here we have 1.5 is equal to 1.2y minus 5.7. So here's the y. What's being done to the variable? It's being multiplied by 1.2, and then 5.7 is subtracted. So we have to go in the opposite order and get rid of the minus 5.7 first. So the inverse of subtracting 5.7 is to add 5.7 to both sides of the equal sign. We don't add it to the variable term, of course. And now we add on the left side and get 7.2 is equal to 1.2y. And then, sometimes people get confused over about what to add it to. You would not add 5.7 to the 1.2y because this has a y in it, and they would not be like terms. You add it to both sides of the equal signs. Only numbers get added to numbers, not to a variable term. And now we have 7.2 equals 1.2y. We look again at the variable and say what's being done to that. It's being multiplied by 1.2. And we need to divide by that to undo it. So now we divide both sides by 1.2. Always look at what's happening to the variable to find out what you're going to do for your operation. This one, to check it, I won't probably be able to check this one in my head because of all the decimals. So I'm going to get my calculator out. And since I have my calculator, I'm just going to put this all, I have a nice scientific calculator, 1.2 times 6, and I can just type in the minus 5.7 all at once, because a scientific calculator will do your order of operations correctly, and I got 1.5, so it did check, and I can move on. Okay, in this one, let's just make sure we know what to add and subtract from what. We have n over 7, that's the same as n divided by 7, plus 2 equals 2. Our variable is n. It is being divided by 7, and then 2 is added to it. We need to undo the adding 2 part first. And so the first thing you would do is to subtract 2 from both sides. And I don't subtract it from the 7, of course, because that's part of this n divided by 7. So that part stays, n divided by 7. 2 subtract 2, 2 minus 2 is 0. So that's interesting. What are we going to get for an answer? 7, 0, something else? So we have n divided by 7. We have to do the opposite, the inverse operation, which is to multiply by 7. But 7 times 0 is 0. Anything times 0 is 0. So we end up with 0 for an answer. Now the checking of this one's interesting. When you put 0 in, we get 0 divided by 7. Well, that's 0. So you have 0 plus 2, and 0 plus 2 is indeed equal to 2. Here are the problems from your worksheet. I didn't include number 1 because that one I did solve and I wrote out the steps, so you can use that one to look back. So I'm going to do a couple of these, and also there's a few more on the next page. So number 3 says 42 equals negative 2 times d plus 6. Our variable is d. D is being multiplied by negative 2, and 6 is being added to it. So we have to think to ourselves, how do I undo the plus 6? And the answer is to subtract 6. So we subtract 6 from the 6, of course, and then you go to the other side of the equal sign and subtract 6. You find the number over there, which is 42, and we subtract 6. So now we have 42 minus 6, which is 36. So 36 equals, on the other side, all that we're left with is negative 2 times d. So we have negative 2, which is multiplied by d, and the opposite of multiplying by negative 2 is to divide by negative 2. So now we have 36 divided by negative 2. And a positive divided by negative is negative. 36 divided by 2 is 18. So we have negative 18 equals d. So this is how your steps should look. You should be first subtracting from both sides, and then dividing on both sides, and then you get your answer. And now I'm going to check this problem by putting my answer back in for the variable. So I get 42, and I want to see if that is equal to negative 2 times, I use parentheses there, times negative 18 plus 6. So now I do the work on the right side and see what I get. So negative 2 times negative 18 is a positive 36. And then I do the 36 plus 6, and I get 42, and 42 is equal to 42. All right, I want to look at number 6 as well. Number 6, we have x is the variable. It is being multiplied by negative 1, and then we have a 9 that's actually added to it. It might not look like 9 is being added to it, but it is, because there's not a plus sign in front of the 9, but it's a positive number, so it's being added. So the first thing that I want to do is undo the adding 9. So how do I undo that 9? I subtract 9 from both sides of the equal sign. So I put a negative 9 under the 9 over here, and then I also put a negative 9 on the other side of the equal sign under the negative 13. So when I write what's left, it's not 1x, it's negative 1x. This minus goes with this term, and I have to write the negative 1x down. Now, negative 13 minus 9, be very careful. That's the same as negative 13 plus negative 9. So check it with the calculator if you want to, but that is negative 22. Whoops. And they're both negative, so you add the numbers together, and then you take the sign of both, which is a negative. Now I have negative 1x equals negative 22. That's negative 1 times x. Whoops. So the opposite of multiplying by negative 1 is to divide by negative 1. And I get x equals 22. Now also, if you get an answer of negative 1x equals negative 22, you can say, well, if negative x or negative 1x equals negative 22, then I could just take the opposite of both of those sides, both of those terms, and get x equals 22. So when you see a negative 1x equal to when you see a negative x equal to a number, you can just assume that the positive of that variable will equal the opposite sign. All right, let's go on. On this page, we have number 8, 9, and 10. These do take longer, but remember that this assignment is worth twice as many points. It's worth 10 points instead of 5 points. So it's okay that it's taking longer because you're going to get more points for it. And it's not going to take you twice as long as a regular worksheet. Number 9 has been started for you. Let's look at number 10. It's got a few negatives that might make it kind of tricky. I wrote x divided by 8. That's the same as x over 8 if you prefer it written that way. And if you're typing these out, this is how you show division, is with that division sign. Some people think it's easier to write these out on paper. I've gotten used to doing it both ways, typing it in Word or writing it on paper, whichever you prefer and however you're able to turn it in. And the first thing that I'm going to undo in this one is the minus 5. So I have the variable is being divided by 8 and then subtracting 5. So I have to undo the subtracting 5 by adding 5 to both sides. So that leaves me with x over 8, or x divided by 8, is equal to negative 10 plus 5. Negative 10 plus 5. That's negative 5. And now I have x divided by negative 8, x divided by 8. So the opposite of that, the inverse of dividing by 8, is to multiply by 8. So these would cancel. 8 over 8 is 1, which leaves me with x equals negative 5 times 8 is negative 40. And I'm going to check it by putting my negative 40 in for x. So I'd have negative 40 divided by 8 minus 5, and I want to see if that equals negative 10. So negative 40 divided by 8 is negative 5. I'm just writing out the rest of this now. Negative 5 minus 5 is negative 10, and negative 10 does equal negative 10, so it checks I have the right answer, which is right here. Okay, so once you're good at solving two-step equations, sometimes we're going to throw in a little bit more work for you to do, some extra steps. You might have to add like terms or use the distributive property before you can start using inverse operations. So here's an example of that. We have 8x minus 21 plus 5x equals negative 15. The variable is here and here. 8 is being is being multiplied by 8, and it's being multiplied by 5. We need to simplify this before we start, adding 21 or dividing by anything. So we're going to simplify by adding our like terms only on this side of the equal sign. There's no like terms on the right side, it's just negative 15. So we're only looking at one side at a time when we simplify. So I have 8x plus 5x. If you want, you can rewrite these next to each other to make it easier to see what the like terms are going to be. 8x plus 5x is 13x. Once you do that, then you'll have a two-step equation like the ones that we've been practicing solving, and you'll be ready to undo your operations. All right, so let's write this out. Now, once you get good at doing these problems, you won't really have to rewrite the 8x and the 5x next to each other. You'll just be able to look at them and find them and say, oh, well, 8x plus 5x, they forgot the 1 there. 8x plus, wait a minute, they forgot their plus sign. This is 8x plus 5x, and this would be 13x. So 8x, because this is a plus sign, the sign in front of a term belongs with it. We assume that this one's positive because there's no sign in front of it. This one is a negative 21, so that negative stays with it. So we have 13x minus 21 equals negative 15. And then our next step is to, whoops, where did my work go? It disappeared. 13x. So then I have to look at my x term, which is right here, and it's being multiplied by 13. and it has 21 being subtracted from it. So then we are going to first undo the minus 21 by adding 21 to both sides. And that will give us 13x equals, and then make very sure that you get this right, negative 15 plus 21 is equal to a positive 6. And then we divide both sides by 13 because that's the opposite of multiplying by 13. And we would have to leave our answer as 6/13, which is not a very nice fraction, but that's all right. Sometimes you'll get a fraction as an answer. I'm guessing that this mistake was that they meant to put a minus sign right here and make it be a little bit nicer at the end, so that's all right. Okay, number 11. Number 11, we have 28 equals 8x plus 12 minus 7x. So we have some like terms here on the right side of the equation. So that, let's see what we would have. We can rewrite them next to each other. When you rewrite them next to each other, the sign in front of the term is part of it. So this is 8x minus 7x, and then I'll write the plus 12 at the end. So now I'm going to go ahead and combine my like terms. 8x minus 7x is 1x plus 12. Now we have a two-step equation. Now we're ready to say, okay, where's the variable? It's right here. It's x. It's being multiplied by 1, which is the same as just having x. And then I have 12 being added to it. So the inverse of that, of adding 12, is to subtract 12. And then you can continue solving this one and find out what you get. In number 13, I want to look at this one. I started this, but I just want to point out why I did what I did. It was 4t plus 7 minus t. And I said that's going to be equal to 3t. And the reason is because you can put a 1 right here. And you can, if you rewrote this with the like terms next to each other, you'd have 4t minus 1t. Remember the sign of the minus sign goes with the 1t. And then I'd have plus 7. So 4t minus 1t is 3t. So you have 3t plus 7 equals 19. All right, sometimes you have to use the distributive property before you can finish solving your equation. So in this example, if you ever have a y and a y, you know you have to simplify before you can start on doing operations. So we have 10y minus parentheses 4y plus 8. This is the same as having a 1 here. Whoops. That's the same as having a 1. We need to take that negative 1 and distribute it through my parentheses. I have negative 1 times 4y, and then I have negative 1 times 8. So let's look at what that would simplify to. We will have, oh, they wrote it out step by step. So we have 10y plus negative 1 times 4y plus negative 1 times 8 equals negative 20. So now that simplifies to 10y, of course. Negative 1 times 4y is minus 4y, or you could write plus negative 4y if you prefer, and plus negative 1 times 8 would be minus 8. And again, if you want, you can write plus negative 8, but it's simpler to just write minus instead. Now we have to look for like terms. They're already next to each other, which is kind of handy. We have 10y minus 4y, which is 6y. So we have 6y minus 8 equals negative 20. And now we finish solving just like earlier in this lesson. It's a two-step equation. We have to undo the minus 8 by adding 8 to both sides. And negative 20 plus 8 is negative 12. So we get negative 6y equals negative 12. 6 multiplied by y. So then to undo multiplying by 6, you divide by 6. And y is equal to negative 2. So this is about as complicated as an equation can get on one side. Now we could make the other side look complicated too, and you'll have to simplify both sides. We'll look at some of those next week. All right, so here we have a little bit simpler example of a distributive property. We are going to distribute the negative 2 through the 3 minus d. So we'll have negative 2 times 3 and negative 2 times negative d equal to 4. Make sure that you see that this is a negative times a negative. So when we simplify this, we get negative 6 plus 2d, because negative 2 times negative d would be a positive 2d, equals 4. And then here's our variable. It's being multiplied by 2, and it has negative 6 added to it. So we could subtract a negative 6, but it's easier to just add 6 to undo the negative 6. And that leaves us with, they wrote the same thing twice. That leaves us with 2d equals 10. And that means 2 multiplied by d. So we need to divide both sides by 2. And we end up with d equals 5. Now I haven't checked the last couple, but let's check this one. If d is equal to 5, then you'll take the value that you got and put it back into the original equation. And when the equations get long, I kind of like to just go back on paper and put a 5 right there, and then simplify. So that leaves me with negative 2 times 3 minus 5. What's 3 minus 5? 3 minus 5 is negative 2. And I want to see, is that equal to 4? And negative 2 times negative 2 is positive 4, so 4 does equal 4, and it does check. So the checking work shouldn't be a lot of work. It should be pretty quick, and you just want to make sure that you got the right answer, so that, especially if you end up with a funny answer, you know, like 5.5 or something, and you go to check it and you wouldn't get it, it wouldn't work. When you do the check, you would get the wrong answer, and then you can go back and try to find your mistake. When you're doing this many operations, it's not that hard or unusual to make a mistake somewhere, especially while you're practicing learning this. That's another reason why it's very important that you show your steps so that I can help you find your mistake if you made any. All right, so here we have just another sample problem. Write this one on a piece of notebook paper, pause the video, and then come back and check if you got it right. So on this problem, we should have done the distributive property in the first part to get 4x minus 8. And then we had the plus 2x equals 40. Now for adding the like terms, you should have got 6x. The 4x plus 2x is 6x. And then we still had the minus 8. Don't lose that minus sign. And then our next part would be to add 8 to both sides. So you get 6x equals 48. And then we will divide both sides by 6 and finally get our answer of x equals 8. So if you got x equals 8, congratulations. You have solved a very kind of complex equation here and did it correctly. If you didn't get 8, go back and see where your mistake was and make sure you understand what it was so you don't repeat it. There's some more problems like this on your worksheet. I'm going to look at I'll do number 15. We have 2.4 equals 3 parentheses m plus 4. This tells us to go ahead and use the distributive property. So 3 times m is 3m, and 3 times 4 is 12. And now we have a two-step equation. Here's the variables m. It's being multiplied by 3, and 12 is being added to it. So I will subtract 12 from both sides of the equal sign. Now be careful with the decimal there. We have 2.4 minus 12. I'm going to do that on my calculator to make sure that I don't mess that one up. And it's negative 9.6 equals 3 times m. So our next step would be to divide both sides by 3 to undo the multiplying by 3. And negative 9.6 divided by 3 is a negative 3.2. And that's what we would get for m. To check this, I would put my negative 3.2 back into my original equation, 2.4, and I want to see if this is equal. So on the right side, I'm going to start by doing the work in the parentheses. I have negative 3.2 plus 4, which is 0.8. So now I need to see what is 3 times 0.8. And I'm checking this on my calculator as I go. And I got 2.4, and 2.4 is equal to 2.4. So this is the correct answer because I checked it and I know it is now. Number 17 is one like we did where you need to put a 1 here and then distribute through the -1 times x and then -1 times 3. Number 18, this is a pretty long problem, but what I did is I wrote the steps out for you. So first you're going to do the distributive property. So 5 times 1 and then 5 times 2w. That's going to equal 5 times 2w is 10w plus 2w equals 29. Okay, the next thing you're going to do is add like terms on the left side. So I've got some like terms there, right here and right here. So when you add those together, 10w plus 2w is 12w, then you'll have 5 plus 12w equals 29. And then here's the final steps. So you might need to take more lines than this because maybe you wrote more steps out to do the distributive property, but these are the main ideas that you will do to solve this problem. Number 19 is another geometry problem, similar to what you'll work on next year in geometry. It says that the sum of two angles is 90. That means that you add the two angles together and it equals 90. Angle ABC is 2x and angle DEF is 3x plus 5. Write an equation that shows that their sum is 90, then solve for x. So I need to say that this plus this is equal to 90. So when you write your equation, you're going to have something plus something is equal to 90. And then you'll combine like terms and finish solving and find what x is equal to. And then the last question is just a critical thinking question, something to make you think a little bit. This equation, 2 parentheses m minus 8, so 2 times the quantity m minus 8 plus 3 equals 17, has more than one solution method. There's only one solution, but there's more than one way to solve this. So it says give at least 2 different first steps to solve this equation. Well, according to what we learned today, we should do the distributive property first. But some people might look at this and say, I think it would be easier to subtract 3 first. So there's 2 different ways, and you just need to write those down. And you don't have to solve this. You can just explain what would be 2 different first steps that you could use to solve this equation. And there is more to this lesson if you're looking in the book, and that is on equations that include fractions. But I didn't put any of those on this worksheet. We'll practice more of these more complicated equations in the Solve Equations Simplify First worksheet, and that will include some with fractions. All right, thank you very much. Have a great day. Remember to show your work and be careful, and let me know if you have any questions. Thanks a lot.